All right, guys, let me shrink this down a little bit. I'm going to talk about it. What did you notice on the table? Where's the table? Let me go. There we go. There it goes. There it goes. What do you notice about this table? Do you see any relationship between the value of the derivative and whether it's increasing, decreasing, max or min? So hopefully you saw when my derivative was positive, when the slope of the tangent line is positive, we're increasing. But when it's negative, we're decreasing. And then my relative max and mins occur when it's equal to 0. That means we've got either a high point or a low point in our graph, right? So we can say 4 different things about this. The first two we just talked about. We said if the derivative at A is greater than 0, so it's positive, then the graph of f of x is increasing at f of A. All right. What did we see when the derivative was negative? So when our derivative was negative, then the graph of f of x is decreasing at f of A. All right. But then we have the derivative being 0. We either have a maximum or a minimum. How can we tell whether it's a maximum or whether we have a minimum? You notice anything special about what's happening near this maximum here and near this maximum here? Hopefully you see, at the maximum, we go from increasing to decreasing. And then what happens at a minimum? We go from our derivative being decreasing, or our graph being decreasing to being increasing. Or our derivative going from negative to positive on the other side. So we can say, two things about that. F of x has a relative maximum. I'm just going to put max if the derivative at A is equal to 0 and f of x changes from increasing to decreasing, f of x, the derivative, so f prime of x, changes from positive to negative, or the graph goes from increasing to decreasing on either side. And we can say f of x has a relative minimum if f prime of A, what is f prime of A? Derivative, the slope of the tangent line, keep drilling that home. If the slope of the tangent line is 0 and our derivative changes from negative to positive. In other words, our graph itself goes from decreasing to increasing on either side. All right, so that's what we can pull from that table. Let's take another look at this table. So sometimes we don't have a graph to find our derivatives from. Sometimes we can find the estimation of a derivative from a table. If we look at the points on either side, and we're going to go right back to our old school slope formula. So if I want to know the estimation of the derivative at this point here, and remember, this is an estimation. This is not exactly what it is, just like we couldn't exactly tell what the slope of the tangent line was on the graph. I'm going to find the point on either side of it and use the slope formula from Algebra 1 to come up with an estimation of the derivative at 0. So f prime at 0 is approximately equal to this y minus this y over this x minus this x, right? So negative 3 minus 2 over 1 minus a minus 3. That would be negative 5/4. Well, if our derivative is negative, are we increasing, decreasing, max or min? Hopefully you just said decreasing. All right, and to write the equation of the tangent line, we're going to do this 5 million times until it is so ingrained in you, you don't even think twice about it. Two things we need. We need the point on a tangent line, which at 0, my point is 0, 1. And we need the slope of the tangent line there, which we just said was -5/4. So y minus 1 is equal to -5/4 x minus 0. All right, let's try to estimate it at 1. Now we're looking at these 2 points on either side. So the derivative at 1 is approximately 0 minus 1 over 4 minus 0, which is -1/4. I keep writing equal sign because I know those are equal, but we want this to be the approximation of the derivative at 1. It's negative, so what are we doing there? The function is decreasing. The point at 1 that is on the tangent line is 1, -3. Slope of our tangent line we said was -1/4. So y minus a minus 3 is equal to -1/4 x minus 1. All right, well, what about at 4? Now we're sandwiching with these 2 points. So the derivative at 4 is approximately -7 minus a minus 3 over 6 minus 1, or -4 over 5. Increasing, decreasing, max or min, guys? Decreasing, right? It's negative, so we know it's decreasing. Our point there at 4, which is on our tangent line, is 4, 0. We said the slope of the tangent line was 4/5, -4/5. So y minus 0 is equal to -4/5, x minus 4. And make one more approximation, this time at 6. So the derivative at 6, the slope of the tangent line to our function at 6 would be 2 minus, wow, I just cannot get away from an equal sign today. 2 minus 0 over 10 minus 4, which is 2 over 6. We are approximately at 1/3. Ooh, 1/3. What's different about this one then? Increasing, decreasing, max or min? It's not 0, not negative, so it must be increasing. All right, point on the tangent line there is at 6, -7. Slope of tangent line, we just approximated at 1/3. So y minus a minus 7, 1/3, x minus 6. All right, come back for video number 3. We're going to do some more graph work again.